We are going to study Science and Technology Part 1st. But before that, do subscribe my channel and click the bell icon for notification. Chapter 4, Effects of Electric Current. We have learned in earlier standards about static electricity. We performed various experiments regarding negatively and positively charged objects. The reason behind the object becoming positively and negatively charged is the transfer of negatively charged particles from one object to another object. In previous standard, we also studied about electric current. So now, in this chapter, we will study about electric current flowing through a conducting wire, an electric current flowing through a resistor, electromagnetic induction, electric motor and generator. Figure 4.1 shows how electric current helps in the working of electrical appliances. Energy transfer in electric current. To understand how energy is transferred in electric circuit, let us perform an activity. Take materials like connecting wire, electrical cells, electrical resistance, voltmeter, ammeter and plug key. Procedure. Connect the circuit as shown in figure 4.2. Taking the components with proper values. Measure the current. Also measure the potential difference VAB between the two ends A and D of the resistance. The potential at A is higher than the potential at B, as the point A is connected to the positive electrode of the cell and point B to the negative electrode of the cell. If charge Q flows from A to B, work VAB into Q has been done on Q while going from A to B. From where does the energy come to do this work? The source of energy is the cell. The cell gives this energy through the charge Q to the resistance where work VAB into Q is performed. If the charge Q flows from A to B in time t, that is, the work is performed in time t, then during that time the energy VAB into Q is given to the resistor. So what happens to this energy? This energy is received by the resistor and is converted into heat energy. The temperature of the resistor is increased. As we know, electric power P equal to energy upon time required is equal to VAB Q upon T, which is equal to VAB into I, since Q by T equal to I. The source of energy the cell gives in time t. The energy P into T to the resistor. If I is the current flowing continuously through the circuit. The heat produced in the resistor in time t will be H equal to P into T, which is equal to VAB into I into T. So, according to Ohm's law, VAB equal to I into R. Substituting this value of VAB in the equation 2, we get H equal to VAB square into TR. Similarly, H equal to I into R into T, which is equal to I square into RT. Hence, H equal to I square into R into T is called Joule's law of heating. Unit of electrical power. As we know, power P equal to VAB into I is equal to voltage into ampere. Thus, 1 volt into 1 ampere is equal to 1 joule upon 1 coulomb into 1 coulomb upon 1 second, which is equal to 1 joule upon 1 second, equivalent to watt. Thus, unit of electric power is 1 watt. The unit of electric power 1 watt is a very small unit. Hence, 1000 watt, that is 1 kilowatt, is used as a unit to measure electric power. In practice, if 1 kilowatt power is used for 1 hour, it will mean 1 kilowatt into 1 hour of electrical energy is used. We can calculate this as 1 kilowatt hour equal to 1000 watt into 3600 seconds, which is equal to 3.6 into 10 raised to 6 watt seconds, which is equal to 3.6 into 10 raised to 6 joule. Thus, 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joule. Heating effect of electric current. When a resistor is connected in an electrical circuit, heat is produced in it due to the current. This is known as heating effect of electric current. Equipments such as water boiler, electric cooker, electric bulb make use of the heating effect of electric current. Electrical conductors having higher resistivity are used here. For example, a coil made up of an alloy nichrome is used in electric heater, cooker as a resistor, as the resistivity of the nichrome is much higher. Due to this high resistivity against the electric current, heat is produced on a large scale, which helps in the heating of the appliances such as heater and cooker. Thus, water is boiled and food is cooked easily. While a tungsten wire is used in electric bulb, as the melting point of tungsten wire is much higher, due to which it has a longer lifespan. If a wire with low melting point such as copper was used in bulb, due to the higher amount of heat produced, it would have melted easily, causing a shorter lifespan of the bulb. As the current that flows through the wire hits the wire up to nearly 3400 degrees Celsius and emits light. The hot wire also radiates heat to a certain extent. Several times we hear or read about building catching fire due to short circuit. Sometimes if we switch on an equipment in our house, the electrical fuse wire melts and electric supply shuts down. Let us discuss about the cause briefly. The home electrical connection consists of live, neutral and earth wires. The live wire and the neutral wire have potential difference of about 220 volt. The earth wire is connected to the ground. Due to a fault in the equipment, or if the plastic coating on the live and neutral wire gives away, the two wires comes in contact with each other and a large current flows through it, producing heat. If any inflammable material such as wood, cloth, plastic, etc. exists around that place, it can catch fire. Therefore, a fuse wire is used as a precautionary measure. We have learnt about fuse wire in previous standard. As soon as high current flows in a circuit, the fuse wire melts and breaks the circuit and any mishap is avoided. As the wire used in fuse is of very low melting point. So when potential difference exceeds than the normal potential, the heat is produced which causes the melting of the wire and the circuit breaks, thus protecting the electrical appliance from high current. Figure 4.4 shows different types of fuse that are used in our daily life. Many times, particularly in summer, huge electrical power is used in the evenings due to home lighting, fans, air conditioners, use of electricity in shops, etc. As a result, excessive current is drawn from the transformer supplying the electricity, and if the capacity of the transformer is insufficient, its fuse wire melts and the supply gets shut down. Such events occur due to overloading. So, these days miniature circuit breakers, MCB switches are used in homes. When this current in the circuit suddenly increases, this switch opens and current stops. different types of MCBs are in use. For the entire house, however, the usual fuse wire is used. Magnetic effect of electric current. We have learned about heating effect of electric current. In previous standard, we have studied about magnets and magnetic lines of force. However, it is interesting to see if electric current and magnetic field are related to each other. Take a look at figure 4.5. Connect the circuit as shown in the figure. Connect a copper wire, thicker and straight as compared to the connecting wires between A and B. Keep a magnetic needle adjacent to the wire. Keep the plug key open in the circuit and observe the direction of the needle. Close the plug key and observe the direction of the needle. What do you notice? Now, interchange the connecting wire connected to the cell and observe the direction of the magnetic needle. Do you notice any relation between the direction of the current and the position of the needle? What do you learn from this experiment? Well, when circuit is open, that is, key is open, no deflection is seen by the needle. It remains in its place. While when the key is closed, a deflection is observed in the needle by the change in its direction. Thus, the magnetic effect is observed because of the current in the wire. This means electricity and magnetism are closely related. Take a look at figure 4.6. Connect the circuit as shown in the figure. When a large current, approximately 1 ampere or more, flows through the thick copper wire passing through a cardboard, the magnetic needle kept at different points on the cardboard around the wire stands in different direction. The direction of the current shown in the circuit is its conventional direction. So what changes are caused by increasing or decreasing current? What do you see when the magnetic needle is kept a little away from the wire? Now, instead of the magnetic needle, spread iron fillings on the cardboard and observe. The iron fillings arrange themselves in a circular manner around the wire. Why does this happen? A magnetic field is produced around a straight current carrying conductor. If the current is unchanged, this magnetic field reduces as the distance from the wire increases. Therefore, the concentric circles representing the magnetic lines of force are shown bigger and rarefied as the distance from the wire increases. If the current through the wire is increased and the intensity of the magnetic field also increases, causing the iron fillings to arrange themselves in a circular manner around the wire. Right hand thumb rule. Imagine you have held the conductor in your right hand as shown in figure 4.7 in such a way that your thumb points in the direction of the current. Then turn your fingers around the conductor. The direction of the fingers is the direction of the magnetic lines of force. Thus, when current is flowing through a conductor, magnetic field is produced around the conductor and the magnetic lines of force are in the circular manner around the conductor. Here are few practice questions. Do answer these questions. If you have any doubt regarding this chapter, do ask in the comment section below. Do like and share the video. Thank you.